Okay, so for today, since this is our first lecture, I'm going to go fairly slow and try to finish the lecture so that we can get benefits for all. And if you have any question, you can always, because I could not see uh, the the screen now. I can only see my PowerPoint slide, and I hope that if you have any issue, you can always turn on the microphone and ask question. So we will, for today, we are going to look into chapter one, and this will take us around nearly 1.5 hours to go into the classifications of aircraft propulsion system. Right. In this session, so we will have three subtopics. We will look into the external combustion engine, and then the aspect of internal combustion engine and other type of engine related to aircraft propulsions. For the first session, uh, the external combustion engine can be divided into three things, three smaller topic, which is we are going to look at the steam engine, Stirling engine, as well as the nuclear engine. So an aircraft engine, all of you probably has already flown in an aircraft. For those who have not yet flown in an aircraft, probably try to buy a ticket to probably, maybe you can visit Kuala Lumpur, visit Malaysia, or you can travel elsewhere to experience what is actually feel in terms of flying in an aircraft. Okay, and normally aircraft engine is known as aero engine. Okay, no, people call it aircraft engine. People also call it an aero engine, which serve as the propulsion system for the aircraft, which is basically a crucial component or the core element in the advancement of the aviation. As you know that the most important component in an aircraft is actually the aircraft engine. This is the most valuable component, right? Of course, the other components are also important, but this is the most expensive component in the airplane. Okay, so the progress of aero engine and aircraft structure have been intertwined since the inception of successful flight. We are not in this particular subject. We are not going to go into the historical aspect and who started flying and all those things. You may want to read through in terms of the historical background. There are many textbooks on aircraft propulsion. You can learn who started to design the aircraft engine from the beginning. The list that I'm going to show you here in terms of the requirements, what are the characteristics of aero engine or aircraft engine that are required for aircraft propulsion system. The first one is that it must be reliable. Reliability is a very important factor that give uh, the most power loss in aircraft poses a significantly greater challenge than in road vehicle, because what happens if the engine is not reliable? Of course, the airplane will just fall down. If compared to a road vehicle, if engine is not reliable, you can just call the motor assistant, right? And then the second aspect is operational resilience, where aero engines must be capable of functioning under extreme conditions of temperature, pressure, and speed, because we know that aircraft will be flying at very extreme temperature, because at different altitudes you will experience a different temperature, different pressures, as well as you can fly at a different speed. The third aspect is the lightweight design. It is imperative for aero engines to be lightweight to avoid increasing the empty weight of the aircraft, consequently preserving payload capacity. Right? And then number four is powerful performance. This is also an important characteristic of an aero engine, where the engines must exhibit substantial power to effectively overcome the combined influence of aircraft weight and drag. If not, the aircraft is not useful. And the fifth characteristic is compact and streamlined. You do not want to have an engine which is very bulky. It will of course increase the drag. So you want to minimize drag. You want aero engine to be designed as small as possible and easily streamlined. Okay. The remaining five characteristics, including fuel repairability. You want to make sure that the engine can be easily maintained, ensuring cost effectiveness. You want it to be fuel repairable, right? Anything happen to the engine, you can easily swap or repair at site. You do not have to uh, bring the engine back to the hangar, to the manufacturer to be repaired. It has to be able to be repaired anywhere. And of course, in the aspect of fuel efficiency, a crucial factor of achieving the desired range of maneuverability, aero engines should demonstrate high fuel efficient. Okay. Uh, the next item is high altitude operation. You want to make sure the engine can are capable to operate efficiently at sufficient altitude, because different aircraft, different type of airplane, it will have to be able to go into different altitude range. And the last two are low noise generation as well as low emission. These are the two aspect in terms of the safety, health, and environment. You want to make sure that your aero engine is being designed to produce the least amount of noise during operation, and the aspect of environmental concern. Okay, so those are the 10 uh, characteristic of an aero engine, meaning that if you are involved in the design of aero engine or selection of aero engine, you may want to consider the factors that are already being explained just now. Okay, in terms of classification, aero engine can be classified based on the input power. Okay, so the three main categories, as being highlighted earlier, there are internal combustion engine, as well as external combustion engine, and other type of power sources or other engines. Right. So if you look carefully here, I hope everybody can see clearly the chart here, classification of propulsion system, where in our uh, subject today, we are going to look into the aspect of external combustion engine, okay, internal combustion engine, and other type of engine. So in external combustion engine, we will look into steam engine, Stirling engine, and nuclear engine, and then we will also look into the internal combustion engine, reaction engine, shaft base. We will go through all of this today, right? And finally, the aspect of solar, electric, and human. Okay, so this is the plan, and this is the plan today, where we are going to go through all of this classification of aircraft propulsion system. All right. First one, 1.1, external combustion engine. Okay, so you have external combustion engine that include the steam engine, Stirling engine, or nuclear engine, where all of the heat transfer occurs within the engine wall, right? So it is through the engine wall. So this is called external combustion engine. So this stand in stark contrast to internal combustion engine. Okay, comparison internal and external is that heat is introduced through combustion fuel, and later on when we look into internal combustion engine, where you can see that the heat being, or the combustion process is occur when we combust fuel within the working fluid body, right? But this one is not. Okay, the external combustion engine. So subsequent section in our lecture will provide a detailed exploration of these three external combustion engine type. Right, the first one is a steam engine. Okay, of course, this is just a picture I took from the book, Aerial Steam Carriage of Hansen and Stringfellow, 1842, steam power aircraft, which refer to aircraft propelled by steam engine. eh. So the uniqueness of from the challenge of creating power plant with a practical power to weight ratio, which is a formidable task due to the technological constraint of time, right? Where we know that steam is generated from water. When you boil water by burning cheap crude oil, and then you have a seal condenser return the steam from the cylinder to the boiler with only 1% loss. Constant pressure in the boiler is maintained by electrical gauges, which automatically ignite the burner when pressure begins to fall, and takeoff pressure can be generated in less than 1 minute. It is the aircraft can be capable of short takeoff and landing operation due to the ease of reversing thrust. So the advantage of a flight of a steam engine, which is it is creating less noise. The benefits of this engine also included the elimination of audible noise. It is very less noise because you just boil uh, crude oil, right? And disruptive vibration, which increase efficiency at both low engine speed as well as the higher altitude. Okay, which was added by lower air temperature, facilitating condensation. Additionally, right, there was a diminished risk of engine failure, okay, leading to reduced maintenance as well as fuel costs. So, despite of all of these advantages, it was discovered that it can be done for small type of aircraft. But if you want to have a employed to a larger aircraft, it already proven impractical. So that's why in contemporary times, there's no aircraft is powered by a steam engine. Okay, so as I said, we are just to go through the example. We are not going to go very detailed for steam engine and the rest of the engine. Today we are going to introduce and to expose to you all type of engine available for aircraft propulsion. The next one is Stirling engine. Okay, a Stirling engine is a heat engine having either air or other gas as a working fluid. So it operates by cyclic compression and expansion of the working fluid at different temperature levels, such that there is a net conversion of heat energy to mechanical output. So you have a fuel there, you have a um, heat energy that being transferred to mechanical energy to turn the propeller, right? Stirling engine also have many advantages like high power density and as well as low cost. It is also quieter, less polluting, gain efficiency with altitude due to lower ambient temperature, more reliable due to fewer parts because it's not that complicated, and the absence of ignition system which produce much less vibration. Airframe will last longer with this kind of Stirling engine, and safer, less explosive fuel may be used. However, they have low power density compared to the commonly used piston engine as well as the gas turbine engine. So this issue made them critical for use in aircraft engine. Okay, the next external combustion engine is that nuclear engine. Of course, nuclear being used to provide power generation. And in our history, there are nuclear also being used to power aircraft. The the two main giants, namely United States as well as the Soviet Union, they have they have programs in order to provide nuclear powered aircraft. Okay, so one persistent design challenge in terms of nuclear engine is that neverly fully resolved was the necessity for substantial shielding, because nuclear operation will have radiation, so we do not want the crew to get sick because of the exposure to radiation. Additionally, consideration were made regarding to the ecological consequences. Like what happened if the aircraft crash, nuclear powered aircraft crash somewhere, and the whole area will be a disaster. Okay, so this is just an example of the US program 1946. I'm not going to go through it. Oops, I'm not going to go through in detail about the uh, program, but it is already being cancelled in 1958 due to many problems. And they have this aircraft B-36 as shown in this picture here. All right. And then we also have the Soviet program, right, using Tupolev aircraft, Tupolev 95 LAL test aircraft. Okay, also being introduced in the 1950s, but in 1966 it is also being cancelled due to budgetary constraint as well as the safety aspect, right? So in other words, the nuclear program, it is very good but very difficult to being managed. So as described for the three external combustion engine, okay, namely the steam engine, Stirling engine, and nuclear engine, they are not appropriate for employment in the aviation field for various reasons. For steam engine, only appropriate for small aircraft, while large aircraft need heavy boiler, piping, and other accessories. Of course, Stirling engine can generate low power, which is also improper for our present type of aircraft. And nuclear engine have two drawbacks regarding shielding of flight crew as well as the risk of crash in resident areas if a disaster happen. Okay, so those are the first aspect of our topic on external combustion engine. Right. Now we want to move into our next subtopic. Okay, as I said, we have three subtopic to look into. The next one is internal combustion engine. So this will take a bit long time. Probably we'll have a short break in between this shaft engine or reaction engine. So the first one, we will look at shaft engine, which include intermittent combustion as well as the continuous combustion engine. And later we maybe continue right after our short break to look into reaction engine. Okay, internal combustion engine, okay, it can be categorized into two groups. One is shaft engine and the other one is reaction engine. So we will look into both shaft type of engine and reaction type of engine. So for shaft engine, it falls into two categories. One is intermittent combustion, the other one is continuous type of combustion. Where intermittent combustion can be classified as reciprocating. Normally, we call it as a reciprocating, or famously being known as a Wankel type of engine or rotary design engine. Whereby continuous combustion engine, okay, we also known as turbine shaft engine, are then subcategorized into turboprop, turboshaft, as well as the prop fan engine. So we will look at all of these as well as the examples. The second major category in internal combustion engine is the reaction engine. Okay, in the reaction engine, it's also being named as an acronym. Acronym is ATODID. ATODID is stand for Aero Thermodynamic Duct. ATHO. DYD, aerothermodynamic duct atodic type of engine, or turbine type. The atodic group normally encompasses or include ramjet engine, pulse jet, scramjet, while the turbine engine include turbojet, turbofan, turbo ramjet, turbo rocket, and advanced ducted fan engine. So all of this we will also look into today's lecture. Right. As previously described, okay, the shaft engines are categorized into two subgroups: intermittent combustion and continuous combustion. Let us look into the first one. Intermittent combustion engine include the Wankel or reciprocating engine. Right. So the Wankel engine is being invented by the German engineer called Felix Wankel in 1950s, where this type of engine being used to employ rotary design to translate pressure into rotational motion. So this aircraft, Diamond DA-20 aircraft, are are using it is using the Wankel type of engine. So this configuration delivers smooth. As you can see that it is a rotary type of engine. So with smooth, high RPM power in a compact size. So you can design the engine in a very compact size and can be employed in the small aircraft and also other type of aircraft like Lockheed Q Star experimental aircraft also use Wankel rotary type of engine. Okay, and Wankel engine also being employed in a few unmanned aerial vehicle type of aircraft. Additionally, the Wankel engines are gaining popularity in home-built experimental aircraft because of its affordability. It's not that expensive compared to certified aircraft engine, which can provide output around 100 to 300 horsepower, which is equivalent to 220 kilowatt at a fraction of the cost of the traditional engine. So you imagine that you can buy it is off shelf. You can buy the Wankel engine at a small fraction of the actual traditional engine. Okay. However, Wankel engine operate at relatively high rotational speed with lower torque, right? Which necessitate the use of propeller speed reduction unit to maintain conventional propeller within the appropriate speed range for propeller-driven aircraft. Okay, so if you want to know more about the Wankel engine, you probably can try to Google in terms of what are the advantages, the disadvantages of the Wankel type of engine. Let us move into the piston engine. Okay, piston engine, commonly referred to as a reciprocating engine as well, is a heat engine that utilize one or more reciprocating piston to convert pressure into rotational motion. Okay, so that the piston engine played a pivotal role in powering first ever piloted motorized achieved by Orville and Wilbur Wright. So probably all of you, if you don't know this, the brothers, the Wright brothers, that flown Kitty Hawk in North Carolina, USA in 1903. Right, it's already more than 121 years now. So since that groundbreaking moment, ongoing advancement using piston engine has already made for aircraft propulsion. In terms of the piston engine, okay, it can also be categorized into 5 more groups. Inline piston engine, we have rotary piston engine, opposed type of piston engine, the V-type piston engine, as well as the radial type of piston engine. So let us go through one by one and see what are the examples being used to propel the aircraft. The first one is inline for piston engine, where inline engine arrange cylinder in a single row because it is that's why it is called inline. It is a the cylinders are being arranged in a single row, which typically featuring an even number of cylinders. Although instances there are also 3 cylinders, 5 cylinders engine exist, but the common one are the even number of cylinders. Early aircraft, including the Wright Flyer, they have 12 horsepower. They accomplish the inaugural control powered flight, commonly employed inline engine. So the Wright brothers also use the type of inline engine. While an inline engine may be air cooled, to cool the engine they use air cool. They are also more commonly use liquid to cool the engine. The primary advantage of an inline engine, okay, it lies in its ability to facilitate the design of aircraft with narrow frontal area. So if you are designing the aircraft, you want the aircraft to be as narrow as possible, and because you want to reduce the drag, you do not want the engine to be very bulky, and it will of course having a broader frontal area. Okay, so if the engine's crankshaft is positioned above the cylinder, so it adopts the label of an inverted inline engine, so enabling the mounting of the propeller at a higher position for ground clearance. This is very important, particularly useful with short landing gear. All right. So there are drawbacks. There are disadvantages for an inline type of engine, which include suboptimal power to weight ratio. Okay, because of the elongated and consequently heavy crankshaft and crankcase. Right. So this is quite critical, because you do not want to have a very heavy engine section. As a result, the inline engine design has become increasingly uncommon in the modern aviation, and also being abandoned in favor for more efficient alternative. Right, that's the first one, and the first type of piston engine. The next one is rotary. Okay, where rotary engine found extensive during World War One. Okay, if you read the history book, they are being used in many type of uh, light aircraft, for fighter aircraft, which is having the characteristic of lightweight. It is powerful, cost effective, and easily producible in large quantity. That's why it's very popular during World War One, because they want to produce as many aircraft as possible in very short time. In a rotary engine, the cylinders are arranged in a circular configuration around the crankcase. So that's why it is called a radial engine. Okay, so the key distinctive distinction lies in the fact that the crankshaft is attached to the airframe while the propeller is affixed to the engine case. Okay, so consequently, the entire engine rotates with the propeller, ensuring ample airflow for cooling regardless of the aircraft moving speed, because you want to cool the engine so that it can work efficiently. And some of these engine adopted a two-stroke design, affording them to have specific power as well as impressive power to weight ratio. However, we want to say that it is regrettably the substantial gyroscopic effect stemming from the weighty rotary engine, it is quite heavy as well, rendered the aircraft challenging maneuver. So it is very difficult to maneuver, because important for fighter aircraft, it has to be high maneuverability. Okay. Furthermore, this engine had a significant drawback in their consumption of large quantities, such as castor oil, spreading it across the airframe and emitting fumes. Normally pilots will feel dizzy, so because of the smell of the oil. Right. The next one is radial engine. This is the third type of the piston type of engine. So the radial engine features one or more rows of cylinder arranged in a circular formation around a centrally located crankshaft, crankcase. Sorry. So to ensure smooth operation, So each row must consist of an odd number of cylinders. Okay, with only one crank throw per row and a relatively compact crankcase, the radial engine achieves a favorable power to weight ratio. So normally the arrangement of cylinders which will be exposed a significant portion of the engine's heat radiating surface to air, resulting in even cooling and smooth operation by cancelling reciprocating forces. Right. So one good example is the Wasp engine, which was designed in 1925. So the radial piston engine, which normally being manufactured by engine manufacturer called Pratt and Whitney, which have a displacement of 1,340 cubic inches. This type of engine dominated normally by the Navy and Army Air Force fighter planes as well as commercial transport, which powered around 100 different experimental and production aircraft. Okay, so in the early 1930s, the P&W, Pratt& Whitney, expanded its radial engine, offering twin row radial engine. Okay, the twin type of Wasp engine produces 1,830 cubic inches and 1,350 horsepower. Okay, and also they have other type of double Wasp engine and so on. The P&W radial engine from the Wasp to the double Wasp reaches a production, licensing, and affiliation over 363,000 engines. So it's quite popular in the 1930s, 1940s, and it is quite a successful type of engine being designed. With cylinders arranged in four rows, and the more modern one, spiraling for enhanced cooling, it can be found primary application in heavy transport and bombers. Okay, in the Second World War, many of the bombers are using radial type of engine, such as the famous B-50 aircraft or Strato cruiser. Okay, right? So this is just another example, 100 horsepower genome rotary engine. So you can see that it is radially situated, and the Pratt and Whitney Wasp Junior radial engine. Okay. For more information, you may want to try to Google and look into the history of the aviation. Okay. Then we have the V-type engine. V-type engine, okay, the picture shows here is the Rolls-Royce Merlin V12 piston aero engine. V-type of engine is also a piston engine, which has cylinders organized in two inline banks, in position at an angle of 30 to 60 degrees. So it is positioned like that. It's like a V shape. And so the cylinders are organized in such way, right? That's why it is called the V type of engine. It uses water cooling, right? And normally being used by small aircraft, light aircraft, Spitfires in the Battle of Britain. And this is just history, right? And then the next one is opposed type. Opposed type of engine features two set of cylinders positioned on opposite side of centrally located crankcase. Okay, example given here, the type of aircraft engine, and this kind of engine can be either air cooled or liquid cooled. Although the prevalence is on air cooled version, the aircraft opposed engine are typically installed with crankshaft positioned horizontally. Normally in helicopters, they may have a vertical shaft orientation. So this type of engine also can be used in helicopters. The arrangement of cylinders leads to the cancellation of reciprocating forces, resulting in a smooth running engine, and opposed engine air-cooled piston with 4 and 6 cylinders are predominant choice for small general aviation aircraft. All right. Right. So we have a continuous combustion engine. I believe it's best to stop here for a while.